when astronauts are going to touch this thing, of course, you want things to be absolutely as perfect as possible because they should not jeopardize the mission on the space station. So that's what also made it very exciting. At times, I thought sleepless night that it may not launch, and there's so many challenges and everything. But eventually, you make hard decisions. That's part of the journey. As a kid, you always dream of nice things, but actually doing things is much more difficult, as everybody will say.
Welcome to Beyond Bosch. I'm Jessica, and today's guest, I'm so excited to talk to him. Dr. Sam Das, he's a principal researcher and SoundSee project lead at Bosch Research and Technical Center in Pittsburgh. Hi, Sam. How are you?
Hello, Jessica. Yes, I'm great.
I'm so happy to have you on here today. I am excited about this topic. So to give our audience an idea of who you are, can you just share a little bit about yourself and what your role is at Bosch and how you got here?
Sure. I'm currently principal scientist and research group lead here at Bosch Research Pittsburgh. So my research group look at various topics at the intersection of artificial intelligence and IoT, Internet of Things. So you could think about all those exciting possibilities that machine intelligence and connected devices and sensors could bring to our world. That's what we research and investigate on.
Wow. I feel like I want to have like 12 episodes with you talking about all of that. That sounds so intriguing. So we're here specifically to talk about SoundSee. And for those who don't know what that is, can you explain just in relatively basic terms first, and then we can dive in a little bit. What is SoundSee?
So SoundSee, as the name suggests, is seeing with sound, right? Common example. If you close your eyes and try to hear all the sounds going around you, it could either be treated as noise, or if you really pay attention, you can imagine, oh, this is the AC sounding, or this is a car passed by my neighborhood. All these stories that gets created in your head when you start to pay attention to those seemingly noisy stuff. When you try to visualize sound in your head, suddenly it becomes more richer as compared to just considering them as noise. So this is what SoundSee envisions to do. Try to make sense of seemingly noisy pattern around us and try to see it or make sense of it. So there's two aspects of making sense of it. One is to understand where it is coming from, whether it is something suspicious or normal, as we humans do all the time. A living room, us hearing a sound outside, or to literally visualize it, like that, to map sounds in space, just like we create maps using light rays, literally seeing the sound patterns in space. So this is the two aspects of what SoundSee envisions to do. But there are a lot of classical signal processing and physics-based techniques that needs to happen in order to do that. That's a research investigation. And also a lot of AI that needs to happen in order to understand whether it's suspicious or is it something normal, right? When you're trying to decode the sound, if you will. So this is what SoundSee is about.
I definitely found myself closing my eyes when you first started kind of giving the example. And I instantly noticed a few things that I did not even know were making noise before I did that.
Yeah.
So how did this idea come about? Why did you all start developing this?
So this is also in the context of how AI has been developing, right? So I gave you the story, what sound can do. But also coming back to technology space, we see that, AI since 2012, I would say, because of certain developments in computer vision, a lot of people started thinking very excitedly about what AI can do for us when you have a lot of data. So, and we saw that a special type of sound being utilized in a very interesting manner and very useful manner in the AI community, which is speech. Speech is, again, if humans are machines, this is the only one type of sound, predominant sound that humans generate, right? And now, of course, you have consumer product like Amazon Echo or Google Home who make sense of those sounds that are generated by humans. But what about those all other kinds of sound around us? How could you also decode them, if you can say the word, decoding the language of machines and things around you, not just humans, right? How do you do it? And can AI help this? You can imagine there's a lot of potential business application. Think about you are driving across the highway and then your car is sounding funny. Maybe you should have heard the sound a little sooner, something like that, right? So you could always get an idea if you could make sense of sounds of machines and decode the language of machines, so to speak. It could be very useful for us. From a business context and research context, we started thinking about those. Initially, we were also thinking about for home monitoring application. We're not around in the house. If an alarm goes off or some loud sound happens and you are on a vacation, you would like to know, right? It's almost like delegating a person or artificial sets of ears to hide in your closet when you're gone and hear all the sounds. Of course, you don't want to do that with a human, but
Right.
how nice it would be if we have an artificial intelligence system with a microphone, of course, and make sense of those. Super valuable, right? That's how we started. And then, yeah, the research still continues because, just like computer vision, just like speech recognition, it takes a long time. So a lot of research goes into making them good or better. And these systems can hear very low frequency sound, which is called infrasonic, that you will not hear, I will not hear, and also ultrasonic, which we are not designed to hear, but these systems can hear. So there's a lot of exciting aspect to which this research field started and still continues on.
Yeah, absolutely. And my mind is going all over the place with where this could be applied. And one exciting application is working with NASA, right? And
Yeah.
SoundSee is now on the International Space Station.
Yes. Dream come true. We launched last November and it's in the space station right now.
How do you feel about that?
Oh, wow. I feel incredible, but it was always my childhood dream. Like many kids who love space, dream about doing something about space. Like you hear about all these spacecraft, Voyager spacecraft or Cassini-Huygens spacecraft. We're not doing that, but sending anything to space that you put your hand on is very exciting, right? And to send something to space station, which is the symbol of human ingenuity at this time for space exploration, right? It's like, how do you build a football field size thing 250 miles above Earth, going 17,000 miles an hour? Is mind-boggling. And even if we have a nut or bolt there, I'll be super happy about it. Having a device like SoundSee is even more exciting. So yeah, it was always, I thought, hey, maybe it's very improbable to eventually launch. We did get the grant, we were doing the research, but always there is so much delta to dreaming something up, building something and testing something here on Earth, and qualifying it to be launched to the space station and to space, of course. And that involves human spaceflight. There's a huge level of robustness and engineering specification that you need to meet when astronauts are going to touch this thing. Of course, you want things to be absolutely as perfect as possible because they should not jeopardize the mission on the space station. So that's what also made it very exciting. At times, I thought sleepless night that it may not launch and there's so many challenges and everything, but eventually, you make hard decisions. That's part of the journey. As a kid, you always dream of nice things, but actually doing things is much more difficult, as everybody will say. And that journey was also very exciting, right? And eventually you say that, okay, everything is go, we're going to go for launch, and then still the launch date moves and everything, and eventually it launches. So this whole, not just that it is in space station, is a sign that the whole journey that went through was quite something life-changing, I'd say.
Oh, I can only imagine. I mean, even just working for Bosch, I get so excited to somehow be associated with the project.
I can tell you, if, I think we got tremendous support from leadership and the company itself and the excitement around it. And again, personally, I would say that there's a lot of opportunities, not just for sound, I'm saying like in the context of space and how Earth's economy will go beyond Earth and go into space. And then that's what a lot of pioneers and leaders are talking about. There's a lot of opportunities to be had from space. So we would like to do projects that goes beyond low Earth orbit of space station and maybe farther, right? This is something not exactly we're doing business yet, but that's the part of also research. That's the exciting part about dreaming up things that is not being done right now, and that makes it all very real.
Yeah. Okay, so it's up there. I mean, SoundSee is up in operation, right?
So we launched, and the first test that needs to be done is that whether or not everything was launched properly. So there is this first operations that we did with the astronauts, which is to do mechanical integrity check and then try and see everything is okay, and everything was okay. And that was the footage we saw at CES, actually. And after that, we have been now working to schedule the scientific experiment at this time, right? There has been some delays, of course, because of operational delay, and also the fact that there has been some delays associated with the schedule, with the robot with which we actually test the system, because at ISS, astronaut time is very valuable. So there's a lot of scientific experiment from universities, from NASA that takes place. So ours is in the queue right now to carry out the scientific experiment. We're working together with NASA, who built a robot on which SoundSee sits actually and flies around. So that robots, they call it checkout activity or commissioning activity, that it can navigate around the space station properly. It knows where it is, and all those things has been verified recently. So we are pretty close to doing the scientific experiment. So actually at this time, we are scheduled to do our first scientific experiment. The more are the chances to have all this experiment to be scheduled and executed. So as you can imagine, our experiment schedule is related to when we'll be having these astronaut launches from the ground, right? And then when the SpaceX launch will happen. So that just being part of that story somehow, although it's delaying our experts, is exciting. That we never imagined that we would be talking those terms. Okay, when are the astronauts going? Maybe we can carry out an experiment. And the fact that I'm talking about this is exciting to me. And then, of course, we want to do the experiments too. But just to give you, the perspective.
Oh, absolutely. Like the fact that you're monitoring that's part of your actual calendar. With
Exactly.
the astronauts. That's pretty awesome. Yeah. So, okay, so what is obviously, SoundSee is trying to make sense of the sounds that humans can't detect. What is the goal having it on the ISS as you're doing these experiments? Like, what is your best optimal situation?
So SoundSee has a lot of microphones. It has 20 microphones, similar microphones that you probably can find in your smartphone, but these are a little more capable microphones. It can hear really low frequency sounds that you and I cannot hear. It can also hear the sounds that you and I can hear, the regular sound, and then also ultrasonic. It goes all the way to 80 kilohertz, which is way into the ultrasonic regime. So what happens is that the goal of SoundSee is going to be two goals in the space station. First is, as I mentioned, it sits on a robot that flies around the space station, modules, and create sort of a map of the acoustic signatures. I'm sure you have seen those videos of automated vehicle with the LiDAR going around on top and creating a point cloud. Imagine doing this thing in the sound space, and you are digitally or using algorithms to focus your listening beam around and rotating around almost like a flashlight in space and then moving around. So what you would create is essentially a similar map of acoustic signature, literally seeing the space in the acoustic domain. And if you think about it, if you're in a space where there's a lot of equipments, just like ISS, and these are equipment, there's no new equipments being installed. This is highly calibrated, engineered space that is there in the space station. And if suddenly a new noise signature comes in, or noise signatures start deviating from what it sounded like for the last months, you'll be able to capture it in this acoustic map. And that's the idea there. For example, in a public domain, there's a leak in the ISS. Imagine the future, these leaks are very expensive for space station because you're venting out oxygen and then you need to launch oxygen cylinders, which cost a ton of money, literally. So leaks actually transmit this ultrasonic signature, which you and I cannot hear. You could potentially spot those and really map those if there is this kind of leaks. But beyond such really subtle cues that could be not so nice for ISS, but also to go close to very important machines. For example, imagine your HVAC system is so important for your house. You cannot let it go bad or anything during summer. You want to hear the sound, and if the ball bearing in the compressor is failing, you would like to know ahead of time. Think about that problem in space station with their life support system machine, which is a complex electromechanical system. It's called ECLSS, or Environmental Control and Life Support System machine. And our goal is to go close to a machine like ECLSS and monitor their noise signature over time and try to spot if there's a subtle deviation from normalcy. This is the part where AI comes in, to quantify how the noise signature is changing over time. And if it is suddenly changing too much, also alert the astronauts that they should go check it out. Even if it is not catastrophic failure, they would like to know. And that's why NASA is also interested in these capabilities. Not that NASA doesn't have a lot of sensors already, great, but there's always more sensing to be done because failures do occur. So sound and analyzing sound with AI is that avenue that NASA is interested in. Of course, we are interested with SoundSee to explore. Mapping the noise signature to literally see in the sound domain, and also to closely monitor specific sound sources and see their changes over time to infer if the source, the machine, or whatever infrastructure is operating nominally or not.
Wow. I'm excited to follow this journey and see where this goes.
Definitely, there's a lot of exciting research. And of course, as you can imagine, there's a lot of on-ground applications. It's not just for space. Anywhere you have a lot of important machines that you don't want them to malfunction, you would like to have technologies like this. But of course, it's always how well you could do it in an environment where you want it to function. It's a noisy environment, whatever. So there's a lot of research that we are doing to make it better, to make it hear as well as possible, even in presence of other noise sources, to really focus its attention to what matters. So that's the part of SoundSee that also excites, because we see that with state-of-the-art AI, there's a lot of possibilities to do that better. It's not that we invented audio signature analysis. It's a decade-old discipline. And what we are mixing with those traditional techniques is the AI, modern AI techniques.
So talking about AI in general, and not just in the SoundSee application, but what do you see in the future for AI?
AI obviously going to impact our lives. It is already impacting, right? The choices we make literally online is governed, behind the scene with algorithms that uses AI, right? What sort of buying preference or personalization, so to speak, the kind of capability that you use at home, for example, in your smartphone or in your smart speaker, all these are AI capable. And then for security applications or for automotive applications, AI is everywhere, which is, allowing us to make sense of signals for automated vehicle or your driver assistance system. It figures out if there is a pedestrian with AI and stops the car. Your smart speaker using AI to do speech recognition, doing these interesting things. So AI is already impacting our life. It will only expand such impact more and more to automate parts of our life which need manual intervention, right? But I would say I like the whole scientific angle of what AI could do, like science as in physics or mathematics side of things. Without going into too much details, there are two ways to look at AI. AI as super intelligent, taking over whatever. I don't want to discuss about that piece because that's still, in my mind, is, a lot of things need to be figured out before that happens. I look at AI, if you say AI, actually a special breed of AI being very popular these days. These are called deep learning, machine learning. And they are really good at representing complex relationship between things. What do I mean by that is that when we are trying to recognize the picture of a cow versus a cat, the way the pixels appear in a cat image versus a cow image are different. And then from that arrangement of pixels and colors and textures to going into saying it's a cat or a cow, this relationship is very complex. There's so many things that needs to be figured out. Oh, this is a geometric shape. This is what the cow's face look like, this, that. You cannot explicitly write down all these rules to be able to recognize this. So this AI machine learning techniques that have been developed, they mathematically somehow or statistically somehow model this by looking at a lot of cat and cow pictures. So I see AI techniques like this as a tool where you could model complex relationship, physical relationship, mathematical relationship between things. When in the past, people used physical sensor to sense something. Like, for example, if you want to sense, like, say, torque inside the axle, you build a torque sensor, or you want to monitor pressure inside your car's engine, you build a pressure sensor. Actually, you could probably do it in a different manner, meaning that these physics-based objects like pressure or torque, this has relationship with other things that are happening as the car operates, meaning the vibration and noises that are coming out of the engine. And if you say that, can you write down an equation that will tell you the relationship between sound and the torque or pressure inside the car? It will be impossible. It's very complex. Even a physicist will not be able to do it because it's so complex. However, with enough data, it is showing that just like you can relate cat pixels and cow pixels to actual labels that is cat or a cow, similarly, the relationship between these really complex physical phenomena, the torque and pressure, could be related to all these other signals like sound or vibration. This is where AI comes in as a tool to really solve mathematical and scientific problems, to really relate things which are not so easily relatable. So that's how I look at it. It's a new way of doing computing. And that's the exciting part. I think it will have application not only in engineering and your consumer products, but it will also change how you do science. In the past, science was done with a lot of data collected, but people couldn't make a lot of sense of those data because there's no mechanism to relate those data points and make sense of it from physics or chemistry standpoint. AI will become a computing tool to relate such complex phenomenon and big amount of data and make scientific outcome out of it. It's a paradigm change of how people think about computing.
I have to say, if for those listening, if you're not feeling the passion from Sam come across, I don't know, because it's just getting me so excited. I haven't really heard AI explained in such a way, Sam, and I feel like that was really helpful.
Thank you. I would think a lot of my peers would think, who are looking at it from a tools perspective. I think in the popular media, it's, again, not saying that people don't have a point in many cases, but it's different lenses through which you could see AI, right? What it does or what it is as a, like I said, as a tool.
Yeah, absolutely. That's very relatable. It's much more tangible for me, someone who is not a scientist and deep into that. So do you have any examples? I'm not sure what you're able to talk about publicly, but do you have anything that you're working on now or coming up that you can kind of tease us about or give us a little sneak peek?
Yeah, of course, we are working on SoundSee. That's our top priority, and we want to validate the scientific hypothesis that I was talking about today in the space station, and obviously take it further and see how these techniques could be used for other setups where you need to do autonomous monitoring of noise signature. So that's one. The other thing, we are thinking AI from that other perspective that I mentioned, right? Figuring out relationship between different phenomena and signals. The work that we're doing also, I'll give you an example of what I mean. You have heard that, AI has been used to do machine translation, and machine translation means translating one language to the other. And Google and Apple has this tools you could use, like from English to German, German to French, and they work with AI and do pretty well. So this is language to language, one language to other language translation, right? And then, as you know, language has grammatical rules of how sentences are constructed, and rules are different for different languages, but you can find relationship between these rules across languages, and that's how you model those and translate English to German or German to French, vice versa. But now think about that same idea when you're talking about physical things. The language of a machine that is being expressed in terms of vibration and sound with the same other language that it is speaking in terms of torque or pressure. The way I look at it, the machines also are talking. It's just that we do not know the grammar rules of those languages because they are language of pressure variation or torque variation. We do not know the physics-based rules, and they're very complex rules, as I mentioned. But with AI, like I said, this is where AI comes as a tool, where you can model such complex relationship, which you cannot model, unlike linguistics for human languages. But in case of physics, it's much more complex. That's why AI comes in and build this relationship between across these signals. Like, we're not talking human language, we're talking about relationship between these signals. And this is what you call signal to signal translation, as opposed to language translation. And you're translating what audio is saying of the machine to what the torque is saying of the machine. And imagine if you can do that, that's exciting, because you can get away with just deploying a microphone and hear the sound and get away with torque signal. And torque sensors are expensive. So this is what the idea we're talking about is called virtual sensing. And this is, as you can imagine, AI is at the core of it. Without AI and AI's ability to relate this complex phenomena in a data-driven manner is helping this.
Yeah, absolutely. I'm seeing so many possibilities and efficiencies too. How did you end up at the research center in Pittsburgh, and why? Why'd you go into this field?
When I came to Pittsburgh as a postdoc research scientist at Carnegie Mellon's Robotic Institute, AI was not what it was back then. We didn't have all this, craziness around artificial intelligence, automated vehicles, and so forth. But it has always been a very exciting field, right? Making machines think like human and do things like human in an intelligent manner. So that's why I came to Pittsburgh, of course, for CMU. But then, as I was wrapping up my research fellowship there, and I was looking for areas where I can apply my knowledge in AI and machine learning, this was, again, 2012. And AI was not that popular at the time. But Bosch, had a very interesting profile. It's, I would say, it's an engineer's dream, right? There's so many different areas Bosch works on, and how you could actually impact those areas with machine intelligence, so to speak. That's why I thought, hey, it's a research lab, and we collaborate also very closely with Carnegie Mellon. So I thought it's a very nice, I would say, quasi-academic atmosphere is what I say. 1 foot in the academia, 1 foot in the industrial research. So I thought it was a very sweet spot for me. So that's how I came to Bosch, and, it has been a very exciting journey.
Wow, absolutely. It's like the perfect fit for you.
Yeah, still.
That's good. That's good. I'm just wondering, is there a specific event or series of events that happened in your childhood or in your life that really got you down this path?
Sure. Yeah. And I would say if I want to talk about passion, definitely space and space exploration, like many other people like me would say, is something that really gets me excited about. And it goes back to childhood, right? I remember I was, I think, in the elementary school or something when there was this 25th anniversary of moon landing, 1984 or something. And there was this magazine article that talked about Neil Armstrong, Buzz Aldrin landing on the moon and all those things, nice pictures and everything. And it was just mind-boggling to me that you look at the moon and people went there. I know this is very common story, but I could tell you from my perspective, it really, like I said, one day, if I built even a small device in that spacecraft that leaves Earth and goes somewhere, that would be my dream, literally, right? And so I never forgot that. Although the research avenue I pursued has correlation with what you could do in space exploration, like AI and machine learning are being applied to space. But if you really feel passionate and strongly, as I mentioned, about something, that you could always find a way. And that's how this whole SoundSee mission came to be, where you could mix your passion, which is space and space exploration, with your knowledge that you acquired from your professional career, which is AI and sensors and whatnot, and mix the two. And that's how this came to be. So I think that's something that I always remember. Anytime I think about SoundSee or anything that we want to do, maybe in the context of space exploration, I just go back to those moments in my childhood where how I felt about those. And I still feel the same way, and maybe more excited, because the possibilities of doing things are even more now with the space industry and everything.
Wow, that's so exciting. And then it also just makes me, as a parent, just like to pay attention to those passions in our kids and those around us, and encourage each other in those passions, because it really comes across with you, and that's what makes it worth it, like you said. I have to tell you, my son is 8 and he is obsessed with space as well. Like his bedding makes it look like he's an astronaut, and
Yeah.
I told him that I was going to be talking to you on the podcast and what you do and all of that. And he seriously, I told him this like a few days ago, and this morning he remembered the day we were going to be talking. He told me, he's like, oh, I can't wait to hear what you hear from that guy, who sent something to the space station, and it's a robot.
So no, this is really awesome. That's the part of the work we do. Is not so much about the project that we have, and if that could get things moving, when you talk to people about it, someone gets excited about it. Even in the company, we went to Bosch Connected World, and then 2 associates from South America came to us and say, oh, this is so cool. I really feel excited about this. And that was the best compliment I got. It's not so much from my bosses or from NASA. It's that, people are excited about the work we're doing, and maybe there will be more such things across Bosch. And that's the hope.
One thing I wanted to ask, either career or personal, do you have a piece of advice that you would like to leave the audience with that has been passed on to you, or that you want to pass on to someone listening?
Sure, it's a very common one. The best advices are the most common ones, right?
Sure.
And never ever compromise on your childhood dream or things that you feel really passionate about. No matter where you are in your life or your career, you could derive your passion and childhood dream out of it if you really look hard enough and work hard enough for it. And that's the thing that would make working on anything worth it at all. I'm sure this is the most common advice, but if you take it seriously, this can do magic.
I love that. No, it's so true. And sometimes we need to hear it, even if we've heard it before. Thank you so much for your time today and sharing just so much exciting information with us, and a peek into the research and technology center and what you do and your team does. Thank you so much for being here.
Oh, thank you, Jessica. It was a pleasure talking to you. Very, very interesting topics, obviously, and happy to share our work.
Thanks for listening to Beyond Bosch Podcast. In case you missed our other episodes, now's your chance. Go back and take a listen.